Hi Matthewy, this is page 4 of our radical packet, and on this page we're going to learn about graphing our radicals. So the first one I'd like to talk about is the square root function. So the parent function is y equals the square root of x. I've not shifted it left or right or up or down or reflected it. It's just the basic graph of the square root of x. And we've done negative square roots, but remember those are imaginary numbers. So the numbers that I'm going to substitute in for x to create our table will be positive numbers, whole numbers, integers, actually. So let's start with 0. When I put 0 in for x into y equals the square root of x, then the square root of 0 is 0. So when x is 0, my y is 0. When I substitute a 1 in for x, the square root of 1 is also 1. So next, let's substitute another value in for x that I can easily take the square root of. So how about we substitute a 4 in for x? When I substitute a 4 in for x, I get 2 for y. Let's pick another number that I can easily substitute in for y. Let's do 9. When I take the square root of 9, I get 3. So I'm going to stop there. That gives me 4 points to plot on my graph. So first of all, I'm going to plot my 0, 0, and then my 1, 1, and over 4 up 2, and then over 9 up 3. And my graph doesn't continue on that far, but I could go over 16 and up 4. This is my graph of the square root function. That's my parent graph that's not been shifted or reflected or multiplied by a value in a that changes its basic shape. So we can do all those things. Let's remember those things. My k, the number at the end, that's my vertical shift. My h, the number inside, that was my horizontal shift. And when I see that one, I have to think the opposite because there's a negative in my formula. And now my A does a couple things. First of all, I need to consider if my A is negative, then I know that it's being reflected down. If my A is a number greater than 1, then my Y values increase by that number. And if my A is a number in between 0 and 1, then my Y values decrease by that number. So when you get ready to graph, you should always consider what's my starting point? Where am I shifting left or right? Where do I put my very first point on my graph? For example, for my parent function, it was 0, 0. And then there's a pattern to graphing. My pattern to graph, my basic graph, is 1, 1 and 4, 2. And then I need to consider, is it reflected? If there's a reflection, I need to consider if my A is not 1, how does that change my movements? So let's take a look at some graphs. The first graph, we'll notice that my A value is 1. So this graph has not been reflected. It's not been any kind of dilation of any type. But I do notice that I move down 3 in the vertical direction. So I'm going to go down 3 from my starting point. And then remember to think the opposite. So I'm going to move over to negative 1. So my starting point is going to be down 3 and to the left 1. So my starting point will be negative 1, negative 3. Remember that if I don't, if my A is 1, then my movements are 1, 1 and 4, 2. So let's do that. So my movement, right 1, up 1, and my movement right 4, 1, 2, 3, 4, and up 2. Do you want to do 9, 3? You could here. It would fit. You could also add 9, 3 if you wanted to. So go back to your starting point, 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 1, 2, 3, and you could see I was just about ready to hit that point. This would be my square root graph when it's been shifted down 3 and left 1. So let's take a look at the same graph, but now my a value is going to be 2. So this doubles my y values. So to get my starting point, I have to think the same thing. I'm going to shift down 3, and I got to do the opposite of what I see inside. So I'm going to shift then to the left 1. So I'm down 3, left 1. My starting point is that same -1, -3. But instead of moving 1, 1, and 4, 2, my y values are now going to double. So I'm going to move 1 and go up 2, and I'm going to move right 4 and go up 4. So I did 2 times 1 to get 2, and 2 times 2 to get 4. So let's go to my starting point, and we go right 1 and up 2. Go back to your starting point. I'm going to go right 4, 1, 2, 3, 4, and I'm going to go up 4, 1, 2, 3, 4. If I wanted to do the 9, 3, I could. It would fit on here. But instead of doing 3, remember my a was 2, so I'm going to really go 9, 6. So go back to your starting point, 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I'm going to go up 6, 1, 2, 3, 4, 5, 6. And you can see my graph would look something like this. Nice. So why don't you try number 3 on your own? Pause this video, try number 3 on your own, see if you can find the starting point and graph it, and come back and let's check your answer. Welcome back. So did you use the correct starting point? Did you use -4, 2? Remember, my vertical shift is the +2, so that's up 2. And my horizontal shift, I have to think the opposite, so it's left 4. So my starting point is -4, 2, and my movements are 1, 1, back to the starting point, 4, 2. And then I draw my graph. Now, I've got a place for domain and range underneath each of these, so let's go back and add that. So my domain is the x values that are on my graph. So you can see for my first graph, my x values start at, sorry, I thought that was on my highlighter, not on my pen. Let me see if I can erase that. And there we go. Get my highlighter. So you can see that my x values start at -1, and they go forever in the positive direction. And you can see my y values start at -3, and they go forever in the positive direction. So my domain and range, my domain starts at -1 and goes to the infinity, and my range starts at -3 and slowly goes up to infinity as well. Let's take a look at the next graph. So on this graph, it's the same starting point. So my x's still start at -2, and they go on forever. So my x's are still, -1. My x's are starting at -1 and going to the right forever towards infinity. Make sure you have a parenthesis on infinity and a bracket on -1. My y values are starting at -3 and going up forever. So my range then starts at -3 and goes to infinity. In my third graph, my x values are starting at x equals -4 and going forever to the right. So then in this case, my domain starts at -4 and goes to infinity. And my range, my y values start at +2 and they're going up to infinity. So my range would be +2 to infinity. So let's take a look at the bottom 3 graphs. So I noticed that number 4 has a negative. So this problem I'm going to deal with having a reflection. So first of all, let's find my starting point. I'm going to go to the left 1 and down 3 for my starting point. My vertical shift is down 3 and my horizontal shift is over 1. But this time, if you notice, this is just like graph number 1, except I have a negative out in front. This means I'm going to reflect it down. So when I do my movements 1, 1, and 4, 2, I'm now going to move that y movement down instead. So let's start at my starting point and go to the right 1 and down 1. Go back to the starting point, go to the right 4, 1, 2, 3, 4, and down 2. And you could even do 9, 3 if you wanted to. It fits on this graph. So I'm going to go back to my starting point, go over 9, and I'm going to go down 3. And I'm going to draw in my graph. So let's go ahead and talk about the domain and range, because my range is a little different for this one. So first of all, my x values are starting at -1 on the x-axis and going to the right. So my x values start at -1 and they go to infinity. My y values are a little different. Let me grab my highlighter. My y values end at -3. There's no y values above -3. But you'll see that because this graph is going down forever, all my negative y values are part of my range. So we say that my range goes from -infinity up to and stops at -3. So don't write this -3, -infinity. We always go smallest to largest, and -infinity, all of these y values at the bottom are obviously smaller than -3. So we would write -infinity first. So let's take a look at number 5. This is like a +0. So as far as my vertical shift, there is none. But I am moving my graph to the right 4. So my starting point, opposite of what you see inside, is going to be 4, 0. So now my graph is being multiplied by a 1/2. That's going to affect my y values. So my 1, 1, 4, 2 is now going to be 1, 1/2 and 4, 1. I'm going to multiply my y values by a 1/2. They're only half as big. So let's go right 1 and up only a 1/2. And let's go right 4. Go back to your starting point and go right 4. 1, 2, 3, 4, and only up 1. So this is a really shallow graph right here. Domain and range. Well, my x values are starting at 4 and then going to the right forever. So my x values start at 4 and they're moving towards infinity on the x-axis. My y values are starting at 0 and my y values then are increasingly going up forever, up to infinity. So let's take a look at number 6. Notice there's no vertical or horizontal shift. This one is going to have a starting point at the origin, 0, 0, and I'm multiplying by a -3. So that means my y values are going to change by a factor of 3. So my 1, 1, my 4, 2, and we'll put 9, 3 on here. So instead of moving 1, 1, I'm going to move 1, 3. 4, 2, I'm going to move 4, 6. And 9, I'm going to move 9 as well. And don't forget we have a negative in front. So this is going to be a down 3, a down 6, and a down 9. So let's get started. So instead of moving 1 to the right and 1 down, I'm going to move 1 to the right, and I'm actually going to move 3 down. And now let's go back to the starting point and go over 4. And instead of going up 2, I'm going to go down, but not only 2, I'm going to go down 6. And let's go back to my starting point and go over 9 and down 9. And this creates this graph that's going down forever in this direction. So domain and range. Well, my x values start at 1 and my x values continue forever in a positive direction. So my domain is 0 to infinity. My y values, though, be careful. My y values are heading down forever. They're going down towards -infinity. So technically, -infinity is the smaller number, and they're going up to 0, which is where they stop. Remember, we don't write 0 to -infinity, even though that's kind of what the graph looks like. It's pointing down to -infinity and starting at 0. It's kind of the way it looks like in our mind. But we always write smallest to largest, so -infinity to 0 then. So let's take a look then at the next. This activity at the top of page 5 is activity where you're going to graph all of these on the same graph. If you're in the classroom, you're going to use different colored pencils to do this. And then why don't you check your answers in the answer key in the folder. And if you're getting one of the graphs wrong or you're getting one of the domain and ranges wrong, then come see me and we'll work on it and see what we can fix for you. So let's move on down to graphing the cubed root function. So if I want to graph the cubed root function, my parent function is y equals the cubed root of x. And I can take cubed root of negative numbers. So I'm going to use some negative values for x in here. We'll use -8, we'll use -1, we'll use 0, we'll use +1 for x, and we'll use 8. And remember, you're plugging it into the equation y equals the cubed root of x. So if we do the cubed root of -8, we'll get a -2 for my y value. If I do the cubed root of -1, I will get a -1. If I do the cubed root of 0, the cubed root of 0 is 0. 0 times itself 3 times is 0. The cubed root of 1 is 1, and the cubed root of 8 is 2. So let's graph these 5 points. So this is my 0, 0. And then I have a point that's 1, 1. And I have a point that's 8, 2. Let's go the other direction. I have a point that's -1, -1. And I have a point that's 8, -2. So when I connect these, it's sort of like my bend from polynomials, but my bend going horizontally. So at 0 is when I switch my directions. This is the graph of the cubed root graph. And my domain and range for this graph would be -infinity to infinity for the domain and -infinity to infinity for the range, because I'm moving right and left forever, and my graph is very slowly moving up and down forever along the y-axis as well. So I can shift this graph just like I did the square root graph. My k is still my vertical shift. My h is still my horizontal shift. And I still have to think the opposite before I do it. My a, if it's negative, it still is reflecting. And if it's a number, it's still changing, number other than 1, changing my y values. So let's take a look at this first graph. I'm not shifting left or right, but I do notice that I shift down 3. So let's shift down 3 and put our starting point. Now, how do I graph my points? You're going to graph just what we had before. You're going to use your -8, -2. You're going to use your -1, -1. You're going to use your 1, 1. And you're going to use your 8, 2. So let's put those 4 points on, starting with my starting point. So from my starting point, if I move 1, 1, I'm right there. Now I'm going to move over 8 from my starting point, and I'm going to go up to, these are small graphs for my eyes. Now I'm going to do the -1, -1. So I'm going to go left 1, down 1, and I'm going to go left 8 and down 2 from my starting point. And now I'm going to connect them. And this would be my graph of the cubed root of x, -3. And my domain and range is -infinity to infinity, because it goes left and right forever, and -infinity to infinity for my range, because it goes up and down forever. You could also use the all real numbers symbol if you'd rather. So what happens when I also have a horizontal shift? So remember to think the opposite. So this is going to shift -1, -3. So I'm going to shift down 3, but I'm also going to shift left 1. And then I'm going to do my same 4 points. -8, -2 from my starting point, -1, -1, 1, 1, and 8, 2. So let's begin with my 1, 1. So I'm going to go right 1, up 1 from my starting point. I'm going to go right 8 over to 7 and up 2 from my starting point. And then I'm going to go left 1, down 1. And then I'm going to go left 8, which would bring me to what? -9 and down 2. And I'm going to trace through those points to create my cubed root of x plus 1 minus 3. Again, my domain and range would be all real numbers. So why don't you try to graph 3 on your own? Pause the video, come back, and let's check how you did. So how did you do? Did you get a starting point of positive 3, positive 2? And then you're going to move your 1, 1, negative 1, negative 1, your 8, 2, negative 8, negative 2 from that starting point. And my domain and range is all real numbers. So let's look at the last 3 on the next page, page 6. So this first one has a negative in front. So I'm going to be reflecting. So a lot of times I use the word reflect down, but technically it's just going to reflect the opposite. So on this one, the right side of my graph will reflect down, but the left side of my graph is going to reflect up. So let's take a look at what this looks like. Let's first get our starting point. Got to think the opposite. So it looks like it's negative 2, negative 1. And then my movements, typically my movements are negative 8, negative 2, negative 1, negative 1, 1, 1, and 8, 2. But since I have a negative out in front, my y values are all going to change. So instead of negative 8, negative 2, it's going to become a positive 2, a positive 1, and then a negative 1, and a negative 2. So I'm going to go, let's start with my 1, negative 1. I'm going to go right 1. Instead of going up 1, I'm going to go down 1. I'm going to go right 8. That puts me at over here at 6. And instead of going up 2, I'm going to go down 2. And I'm going to go left 1. Instead of going down 1, I'm going to go up 1. And I'm going to go left 8. And instead of going down 2, I'm going to go up 2. And so this gives me my reflected graph. Still, domain and range is all real numbers. What happens when I multiply by a fraction? Well, I only do half my vertical movement. So notice that there's no vertical shift here, but there is a horizontal shift to the left 2. I have to do the opposite of what I see. So now I'm going to do my same movements, my negative 8, negative 2, my negative 1, negative 1, 1, 1, and 8, 2, but I'm only going to do half the movement. So only half of what I would have done. My y values are increasing half as fast. So I'm going to go right 1 and only up a half. I'm going to go right 8 and only up 1. I'm going to go left 1 and only down a half. And I'm going to go left 8 and only down 1. It creates a very shallow curve, but this curve is moving. It's not moving horizontally. It is moving up and down. So that arrow is slowly growing upwards. So my domain and range is still all real numbers. Sooner or later, my graph will cover all values on the y-axis, just very, very slowly. Okay, what happens if I multiply by a number greater than 1 and a negative? Well, that's a lot to keep track of. Notice that my starting point is 0, 0. It's not been shifted left or right. And I've got negative 8, negative 2, my negative 1, my 1, 1, and 8, 2 movements. But now, instead of moving 2, I'm going to move 2 times 3 or 6, and I'm multiplying by a negative 3. So it's going to change it to a positive 6 movement. Instead of moving down 1, I'm going to move 3, and I'm going to be moving up because it's the opposite because of the negative. Instead of moving up 1, I'm going to be moving 3, but I'm going to be moving it down. That's my opposite movement because of the negative, and this is going to be negative 6. So let's start. I'm going to go right 1, and instead of going up 1, I'm going down, and I'm going down 3 because of my 3 out in front. And then I'm going to go over 8, and instead of going up 2, I'm going down, and instead of going 2, I'm going 6 because I was multiplying by 3. And now when I go left 1, instead of going down, I'm going up, and I'm going up 3. And when I go over 8, I'm also going to be moving up, and instead of moving up 2, I'm moving up 6. And I'm going to connect these. And I have my reflected graph and my graph that's dilated by my factor of 3. My domain and range is still all real numbers. So the graphing cubed root functions, this one is just more practice. If you're in the classroom, you can use different colored pencils so that you can tell them apart. Find the domain and range, and then check your answers in the folder and come ask me if you have any questions. Let's take a quick look then at the bottom of this page. So on this one, it asks me to graph y equals x squared. Well, that's my parabola. If you remember, my parabola movements were 1, 1 and 2, 4. So I'm going to move 1, 1 and 2, 4, 1, 1 and 2, 4, and I'm going to get my parabola. Remember, it's not really supposed to look like a V. It's a parabola, not an absolute value function. And then it says to graph the square root of x and the negative square root of x. So I'm going to do that actually in blue. So the square root of x we've just been graphing. My starting point is 0, 0. And I go over 1, up 1. And I go over 4, up 2. And this is my square root of x graph. Y equals the square root of x. So now let's do y equals the negative square root of x. So I'm still going to start at 0, 0, but when I go over 1, I'm going to go down 1 because it's the negative square root of x. And then when I go over 4, I'm going to go down 2. And you'll see that basically I'm getting a sideways parabola. That's because the square root function and the quadratic function, those are inverses. And when functions are inverses, they are a reflection in the diagonal line y equals x. Y equals x is the diagonal line that goes through the origin, that goes through 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. This is the diagonal line moving through my graph. And if two functions are symmetric about the line y equals x, we say that they're inverse functions, inverses of each other. So thank you very much, and I will see you in class.